All right, so today we're going to finish reviewing for test one. Because remember, this Sunday, the things that are due are going to be 3.7, review for test one and test one. And remember, on the review, you can take it as many times as you want. You want to try to get the highest score that you can. Because once you do that review a few times, you'll notice that the test is going to be very similar to it. Okay, so our first one, we went through 17 on Wednesday. So we'll start with 18. It says to use the horizontal line test to determine whether the function is 1-to-1. And remember what the horizontal line test says. The horizontal line is kind of like the vertical line test, right? Remember, the vertical line test is what you use to determine if a correspondence is a function. The horizontal line test, the one that goes straight left to right, is what you use to determine if the function is 1-to-1. A horizontal line, if you could draw a horizontal line and if it touches your graph more than once, then it is not a 1-to-1 function, right? The 1-to-1 function, a horizontal line would only touch the graph one time. So this one is not 1-to-1. Now, on number 19, the first thing it's going to ask you is determine whether it's 1-to-1 or not. And if it is 1-to-1, we're going to find the inverse of it. Okay, so the function that it gives me
is this 18 or 19?
This is 19. That one was 18.
Okay.
Now this one's 19. It says determine whether the function is 1-to-1. If it is, to find the inverse. So f of x equals 3 over x plus 4. So to determine if it is 1-to-1, I can put this in y equals and see if it does pass that horizontal line test. So if I put it in y equals, I'll do 3 divided by, now I'm going to put that x plus 4 in parentheses to contain that all in the denominator. So open parentheses, x plus 4, close. And then graph it. So when you graph it, you'll notice that it will pass that horizontal line test, right? Everywhere I draw a horizontal line, it's only going to touch that function one time, which means it does pass the horizontal line test, which means it will have an inverse. So the steps to finding the inverse of this function is to rewrite it with this being a y, right? Because f of x and y are the same thing. So you have y equals 3 over x plus 4. Once you rewrite it with the y, you're going to invert your x and your y. So wherever you see a y, you're going to put an x. And wherever you see the x, you're going to put a y. So this will turn into x equals 3 over y plus 4. Then once I invert the x and the y, then I'm going to solve for where my new y is. So this is the y now that I want to get by itself. Since your y is in the denominator of a fraction, the first thing you need to do in order to get it in the level playing field instead of in the denominator so you can isolate it is you're going to have to multiply both sides by this denominator, because it'll cancel the y plus 4 over here. And then once I multiply it over here, it's not going to be in the denominator anymore. Okay, so if I multiply both sides by y plus 4, again, it'll cancel it over there, so you just have the 3. On the left side, I'm going to distribute that x. So x times y gives me xy plus x times 4 gives me 4x. So again, now here's the y that you're trying to get by itself. So the first thing I need to do is get rid of that plus 4x. So I'm going to subtract 4x. So there's my xy equals. These don't go together, right? You just bring them down separately since they're not like terms. So you'll have 3 minus 4x. And then what are you dividing everybody by? That x, right? To get that y by itself. So the x's cancel. So there's your y all by itself. Equals 3 over x minus what happens to these x's right here? They cancel because you have x over x. So you just have minus 4. Put the x in front because I'm not going to graph because I knew somebody was going to ask that. But yeah, you can. I could have put negative 4x plus 3 and still divided by x, which would have left you with x, or excuse me, 4 minus 3 over x, which is totally fine. Is that what you had? Oh wait, negative 4 plus 3 over x would have been the same thing. I probably should have just done it like that. All right, the next one, number 20, is when we got into the systems of equations section in 3.6. The first one that we're going to work with the systems of equations just has 2 equations with 2 variables. So 4x plus 3y equals 40. And 3x plus 4y equals 44. Okay, now I can do this in my matrix function and just create a 2 by 2 and a 2 by 1. Okay, I'm going to solve this one by hand because that's what we did when there was 2 equations and 2 variables. You can do it either way. So if I'm going to solve this by hand, you either need to be able to add these 2 equations together and cancel out your x's or your y's, which means it doesn't matter which one. If I'm going to cancel out my x's, I need them to be opposites of the same number. So what is the first number that 4 and 3 go into evenly? 12. So you want them to be opposite 12s, one to be positive 12 and one to be negative 12. So, and it doesn't matter which one. If I make my top one positive 12x, it needs to be multiplied by positive 3 on both sides, which means this one needs to be negative 12. Good, which means you need to multiply it times negative 4. So let's see, on my top row, 3 times 4x gives me 12x. Plus 3 times 3y is 9y equals 3 times 40, 120. My second row, negative 4 times 3x is negative 12x. Negative 4 times positive 4y gives me negative 16y equals negative 4 times 44 is negative.
Negative 176.
176. So now I can add the two equations together because my x's will cancel and I will just have an unknown y. So positive 9 and negative 16 gives me negative 7y equals 120 minus 176 is negative 56. So now I can solve it for y by dividing both sides by negative 7. So y equals positive 8. Go ahead. 20. Now that you know the y, what can you use it for? You can take it and plug it in that top equation for the y, which means you'll be able to solve for x. So if I plug it in for y, I'll have 4x plus 3 times 8 equals 40. So 4x plus 24 equals 40. Solving for x, so subtract 24 from both sides. So 4x equals 16 and divide by 4. So x equals 4. Now remember what you're doing when you're solving a system of equations in two variables is if you solve those both for y, put them in y equals and graph them, they would make two lines that would cross. Okay, they're going to cross at a certain point, which is what you're finding. So when you enter your answer, you need to enter it in as a point, which is an ordered pair, right? So by ordered pair, your x always comes first, so it'll be 4. And the y is 8. Now, when we get into 21, we're going to have 3 equations and 3 variables. So we're going to use the matrix function in our calculator to solve it. So 6x minus y plus z equals negative 8. 2x plus 2y minus 3z equals negative 31. And x minus 3y plus 2z equals 22. So we're going to create 2 matrices. Matrix A using the coefficients from the left side. Going across the top row, I'll have 6, negative 1, positive 1. My second row, 2, 2, negative 3. And my third row is 1, negative 3, 2. Then I'll create a matrix B with the right side. So negative 8, negative 31, and positive 22. Now, I'm actually going to use the second matrix function because I don't think it happened in this class, but my 11 o'clock class, for some reason, they don't have 2 people when you did, what did you do? Alpha Zoom. Alpha what?
Alpha Zoom.
Alpha Zoom. It took them somewhere else. You know what?
Maybe they haven't. You can update your calculator.
Maybe it just need to be updated.
Yeah, you just have to plug it into the computer with a cord and then get on TI and it has an update on the website.
So I'm going to use the second matrix function to create these 2 matrices. So just go to second matrix. Now remember, the first thing you're doing is editing. So go over to edit and edit matrix A. Enter your number. So first of all, tell it 3 by 3. So just 3, enter, 3, enter. And then enter across the rows. So first row, 6, enter -1, +1. Second row, 2, 2, -3, and third row, 1, -3, 2. So again, just create that matrix and then create the matrix B. So second matrix, still editing. So make sure you go over to edit and then go down to B. And this one is a 3 by 1, right? Because it's got 3 columns. I mean, excuse me, 3 rows and 1 column. And enter the numbers from that matrix. So -8, -31, and 22. Now you want to go to the home screen. So just hit your second button and then the button right now, the mode button right next to it to get to your home screen. And now you want to do matrix A to the -1, matrix B. So second matrix A, so hit enter. Then hit the X to the -1 button, and then second matrix, go down to B. Enter. So there is your X, Y, and Z, -3, -5, +5. And again, you're going to enter this as it's called an ordered triple. -3, -5, +5. All right, 22. This is the one talking about the egg, the cupcake, and the pizza and their cholesterol. So we're going to translate each of the statements into an equation. The first statement says a child eats 1 egg, 1 cupcake, and 1 slice of pizza. So I'm going to use E for egg, C for cupcake, and P for pizza. They eat 1 of each. Egg plus cupcake plus pizza. It tells me they consume 302 milligrams of cholesterol. The second statement says the child eats 3 cupcakes. So 3C. And 4 slices of pizza. So plus 4P, the child takes in 92 milligrams of cholesterol. The last statement says by eating 2 eggs, so 2E, and 1 cupcake, so 1C, a child consumes 568 milligrams of cholesterol. So when I turn these 3 equations into a matrix, I can't just leave blank spots in my matrix. What's going to go in each of these, right? So this matrix, 1, 1, 1. Second row, 0, 3, 4. And third row, 2, 1, 0. And then matrix B, yeah, 302, 92, 568. So again, go to second matrix. Now remember, we're creating new matrices, so make sure you go back over to edit and hit enter. It's still a 3 by 3. And enter your new numbers. So 1, 1, 1, 0, 3, 4, 2, 1, 0. There's matrix A. So now I need to do matrix B. So second matrix, back over to edit and go down to B. It is 3 by 1. And enter your numbers. 302, 92, and 568. And then you'll do matrix A to the -1, matrix B. So second quit, first of all, to get to your home screen. Then matrix A, so second matrix A to the -1, second matrix B. And enter. So there's your cholesterol, 274 for the egg. The cupcake is 20 and the pizza is 8. Now, the last 3 problems are from 3.7, where we did the inequalities, where we did the graphing the line, and then we had to determine whether it was solid or dashed, and then do your shading. Go ahead. So 23 is going to give us an inequality. The first thing we're going to have to do with this inequality is get the y by itself. Okay. Now remember going over the rules of inequality. Sometimes it's dashed. Dashed lines are when there's not an equal to bar. Solid lines are when there is the equal to bar. So on number 23, you have 4x minus 5y is less than or equal to -15. So the first thing I'm going to have to do is solve it, get the y by itself so I can take it to my y equals and get 2 points to plot. So getting y by itself, so I need to subtract 4x. So now I have -5y is less than or equal to -4x minus 15. And the last step to getting this y by itself tells me I'm going to need to divide by -5. And what happens when an inequality is divided by a negative?
The sign switches.
Right. That inequality symbol is going to flip around, which is going to affect your shading. So y instead of less than now is greater than or equal to. Negative over negative turns to positive 4/5 x. Negative over negative again, and that reduces to positive 3. Go ahead.
Why does it flip? I was here.
Anytime you divide or multiply by a negative number in an inequality, so I've divided by a negative, that's when this flips around. So now I'm going to take this to my y equals. Clear it out. So 4 divided by 5x plus 3. And I'll graph it just to make sure it's a line, which it is a straight line. And then second table to get 2 points in order to plot it. There's a lot of points where the y is a decimal. Just avoid those. So I see 0.3 is a good one, and 5.7 is a good one. So let's plot these 2 points, 0, 3, which will be left and right 0, up 3. And then 5, 7. So to the right 5, 1, 2, 3, 4, 5, up 7. And now remember, Math Lab is going to connect that with a solid line. Do we want it to be solid?
Yes.
Yeah, if it has the equal to bar, we want it to be solid. Here's what you're graphing. Y is greater than this line. Where are the Y values greater than this line? Above it. So you'll click that paint can in your toolbox and just click anywhere above the line. It'll shade that whole region. Number 24.
How many problems are left in the review?
This one and one more.
Oh, okay.
X is less than 1. So remember, this makes a special line. When I'm making my XY chart, all the X's in this line have to be 1s, right? There's not an X and a Y, so I'm not taking it to Y equals. The X's all have to be 1s in every point that you're going to make. It matters none what the Y is. Just make up whatever you want. So this one's at 1, 0. So to the right 1, up and down 0. There's where X is 1. To the right 1, down 2. So right 1 again, down 2. So you'll see what kind of line this is going to make. It's going to be a vertical line. If I did this one, which I won't have to, right? It'll connect them after 2 points. To the right 1 again, and up 3. So this time when it connects as a solid line, I'm going to need to change it to a dashed line. Okay? There's like a little toggle switch over in your toolbox that looks like that. Just click on the dashed. That'll change your line to dashed. And this one says, where are the X values less than this line? So since it's vertical, I can't shade above or below it like I'm used to. I'm going to have to shade right or left. Where are the X values less than where they are right here? To the left of it. Last one. This one has 2 inequalities that we're going to put on the same graph, do the shading, and the answer is where the shading of each of them overlap each other. And this one will be multiple choice. The first one is y is greater than or equal to x plus 4. And the second inequality is y is less than or equal to 3 minus x. So I'm going to put this one in my y equals first. So if I go to y equals x plus 4. And then I'm going to get 2 points from the table. So hit second table and just pick whatever 2 points you want. I'll do -1, 3 and 0, 4. To the left 1, up 3. Left and right 0, up 4. And these are both going to be solid lines, right? Since they both have the equal to bar. So my first one says, where is y greater than that line? Greater than means you shade above. Now put this one in your y equals. So 3 minus x. then second table for it. And I'll do -1403. And I'll do this one in red. So to the left one, up 4. Left and right 0, up 3. And this one's also connected with a solid line. But this one says where are the y values less than that red line, which would mean below it. Now, this one is multiple choice. On A, B, C, and D, they actually have the same exact 2 lines on all 4 options. The only thing that's different is the area that's shaded. They have the different quadrants shaded as the different choices. You want to choose the one where the shading is overlapped, which is that one. That'll be the only one that is showing as shaded. Okay, all right, are there any questions?